Further work with coefficient. So we established when we did one of the previous questions, finding term 4. Okay, so we established that we need to let k equals 3. Alright, so putting that into the formula set, we've got the k plus 1 term is going to be nck a to the power of n take away k times b to the power of k. Alright. So whatever term number you need to deduce one for the value for k. Okay, so if you need the 4th term, you need to let k equal to 3. If you need the 10th term, you need to let k equal 9 in this part over here. Okay, so examples, find the general k plus 1 term of the binomial product of that. Okay, so term k plus 1, so using the formula, so n is 8, ck of that product. So a 4x cubed to the power of 8 take away k and times b to the power of k. Okay, probably would try to bend out, but it's not really going to benefit me in any real way. Okay, because I'm still having paid k. But find the coefficient of x to the power of 5 in that expansion. Alright? So I have the binomial product of x squared plus 2 over x, or to the power of 7. I need the coefficient of x5, x to the power of 5. Any suggestions on how I'm going to do this? Pardon? Okay, let's start with that. So t to k plus 1, so n is 7, ck, x squared to the power of 7 take away k, times 2x to the negative 1 to the power of k. Using your next laws there. Pardon?
Is k 4?
Not necessarily.
And what's the significance of x 5?
Okay.
What find the coefficient of x?
So,
What are we doing?
you're finding the coefficient of x to the power of 5. Okay, so yes, we need to use this formula. How do I then use this formula to set it up so that I can get the correct coefficient? Okay, can you expand this using your powers of the power? Okay, and that also 7ck x to the power of 2 times 7 take away k, so that would be 14 take away 2k, using your power to a power. Two to the power of k, and then x to the power of negative k, using your power to a power index law. What can I do now? Well, before we can substitute, so we need to find out what the value of k is, alright, and how do we work that out? Any ideas?
Eliminate x.
Pardon?
Eliminate x.
Eliminate, we'll still need x because that's the significance for here. This is x to one power times x to another power, isn't it? So I use my index clause there. So x to the 14 take away 2k plus a negative k when I'm multiplying. So that becomes a 14 take away 2k take away k. So 14 to the power of negative, x to the power of 14 take away 3k times 2 to the power of k. Yes, no?
Why don't we just get K and then put it straight into the top one?
What's V for K then?
Very fine.
Well, exactly. So before you can do that, you need the value for K, don't you? You need to work out what value for K would give you this correct power here.
Wouldn't K, since it's the times a negative K, just become negative K?
So? Right, this is x to the 14 take away 2k times x to the power of negative k. Putting the k terms together. Alright, when I'm multiplying, I add the indices together. So it'll be negative 2k plus a negative k because of the 14 take away 3k with the 14 there as well. Okay? And now I want x to the 5, don't I? You've got it. So that means 14 take away 3k must equal 5. Okay, so in other words, x to the power of equals x to the power of that. Okay, so you need to set this up, particularly when you have variables of x for both a and b, okay, where it's not so straightforward for me to say, you know, k is this value. Alright, so negative 3k is equal to 5 take away 14, which is negative 9. So k is 3. Once I determine that value for k, I can then go back up to this step here and substitute in for k for my coefficient. Because 14 take away 9 is 5. And that will give me the term with x to the power of 5. Okay, so coefficient is going to be 7ck, where k is 3, and times 2 to the power of 3. Don't need to put my x there because I just need the coefficient. If it says term, I will also need to include x to the power of 5. Okay, what is 733 times 8? That independent of x in that expansion. Alright, so what does it mean to be independent of x? Pardon? It's a constant, so what's the power of x in this example?
18.
So if it's a constant term, what's the power of x? 0. X to the power of 0 is 1. Alright, so turns to k plus 1 is equal to 18ck, 2x to the 18 take away k. I'm just going to write it like this, so 2 to the power of negative 1 to the power of k, and x to the power of negative 1 to the power of k. But I do have a negative there as well. I'm going to make that negative 2. Okay, so do you understand what I did with these two terms here? Alright, tidy it up and group all your x terms together. So 18ck, so we have 2 to the power of 18 take away k, x to the power of 18 take away k. We have negative 2 to the power of negative k, and we have x to the power of negative k. Using your power to a power.
Why is it to the power of negative k?
Sorry? because 2 and x are on the bottom of this fraction here. Alright, so 18ck times 2 to the power of 18 minus k. So this should be a negative 2 bracket because I'm not subtracting. Then negative 2 to the power of negative k. And then we have x times x with different powers, so we add the powers. So x with 18 take away k plus a negative k. To be x to 18 take away 2k. So we want x to the power of 0, don't we, for the term independent of x. Alright, so that implies that my 18 take away 2k must be equal to 0. Alright, the rate of k that works is what? None. Okay, that's very straightforward equations there. Right, so coefficient of term k plus 1, so k is 9, so give me term 10, is what we're looking for. In the 19 terms for that expansion will give me x, the term independent of x. Okay, so it'll be 18c9 times 2 to the power of 18 take away 9 times a negative 2 to the power of negative 9. Do you dare put this in the calculator?
Can I just cancel it out?
So,
2 9 whichever one?
well, yeah, we can, I guess, yep. Mathematically, it makes sense, yep. So what's 18c9? Is it some?
48,620.
I was expecting it much bigger than that. 48.
620.
X squared take away 1 on 2x. X squared. No, it's not. What have we done wrong?
18c9. Wait, is it negative 19?
It doesn't matter, we've got a fraction there. At this point, I'm not concerned about negative, I'm concerned that there is a fraction there, and I don't have that here.
Well, where are we this up?
2x. Ah, I'll put 2x, not x squared. Okay, but the principle there is there. So that's the correct answer for if it was 2x, take away 1 on 2x. I'm not going to go through that. Okay, but it helps to write down the correct thing at the very start, because if you were doing anything there and you spent, what, close to 6-7 minutes on this, and then you realise at the very start of the question you made a mistake.
Would we still get a mark?
Yeah, okay, so this will probably be a 2 or 3 mark question. Yes, you show me the procedure that you're finding value per k and then using that to find the coefficient. Yes, you'll get your partial marks if you continue, okay? But you won't get your full mark because that's obviously not correct, okay? So, correct answers are obviously important, okay? But what I'm concerned about right now is that you guys are understanding the process, okay, to get the answers. Right, the ratio of the coefficients of the terms in x to the power of 11 and x to the power of 5 of x squared plus 1 on mx to the power of 7 is 1 over 5. Take it in. Find the value for m. Now in your notes, this is a k. Alright, but we've got k's in our formulas, so just change that to an m. In your note, because otherwise you're doing your NCK and then you're going to have k terms in there, and it's just not, it's misleading, sorry, to have find the value for k in those two expressions. Right, so my apologies for that. Okay, so the ratio of the coefficient. So the coefficient of x to the power of 11 and the coefficient of x to the power of 5, the ratio of those, so if I do x to the power of 11 divided by x to the power of 5, the coefficient will simplify down to 1 over 5. Okay, so that's that context. We need to find the value of m that makes that work. Alright? So, you don't have much of an idea, okay, right, based on your reaction. But what if you had this in your exam, okay, this was a 3-mark question, where would you start? What could you possibly do? Pardon? Yeah, I'll start with that. Alright, so we got n is 7, x squared to the power of 7 take away k, and mx all to the power of -1 to bring that to the bottom of the fraction. Okay, you can write it as fractions if you wish. Alright, I'm just writing it as negative index. All to the power of, sorry, not 7, k. Okay, let's tidy that up as much as we can. Okay, so combining a few index laws there that we did way back in mathematics term 1 this year. Using index laws there to be x to the 14 take away 3k times m to the power of -k. Okay, I need to find the coefficient, so I can find the ratio of these two coefficients and show that it's 1 on 5, don't I? Okay, so I'm doing the same work as before. So I need the coefficient of x to the power of 11 and I need the coefficient of x to the power of 5. Alright, so x to the power of 11. So I need this power, so 14 take away 3k. I need that to equal 11, don't I? So 14 take away 3 is 11, so therefore k is 1. Yep. Alright, x to the power of 5. So 14 take away 3k must equal 5. What's the value for k? 3. 14 take away 9 is 5, so k must be 3. Okay, if you can get that far, you're certainly on your way to getting a solution. Alright, so k is 1 means your second term is going to have x to the power of 11, and k is 3 means your fourth term is going to be k to the power of 5. Alright, so term 2 is going to be 7c1 times x to the power of 11 times m to the power of negative 1. Term K3, so term 4, going to be 7c3 times x to the power of 5 times m to the power of negative 3. Right, what do I do now? Yep, how do I set it up? Well, we know what? So know coefficient of x to the power of 11 over x to the power of 5 is in the ratio of 1 to 5 from the question. The ratio of the coefficient of the terms in x to the power of 11 and x to the power of 5 is equal to 1 over 5.
So
Yep.
the coefficient of x6 is 1 over 5.
Sorry?
The coefficient of x6.
Yes, but we don't need to go to x6. So, right. Right, so x to 11, so 7c1 times m to the power of negative 1 over, so I'm writing the rest of the term without the variable, and then x to the power of 5, 7c3, x to the 5 times m to the negative 3 must equal 1 over 5. Now we have an equation solved. So 5 times 7c1. Now, division is a subtraction. So m to the power of negative 1 divided by m to the power of negative 3 is a subtraction. So negative 1 take away a negative 3. Okay, cross multiply, remove the denominators. So, m squared must equal 7c3 over 5 times 7c1. M squared is 1. So what's your value for m? Plus or minus 1. Okay, so I have actually done this question yesterday. When m equals 1, it becomes 35 x to the power of 11 plus plus 5, sorry, plus 7 x to the power of 5, and 35 divided by 7 is 1 over 5. Alright, when it's negative 1, this becomes a negative 35 x to the power of 11 and a negative 7. x to the power of 5. So you can check that expansion and check your answers at the end. Okay, now that is exercise 10.2, sorry. 10.3 is the expansion of a plus b to the power of n, and we've still got a couple more things to do in that which we'll work on next week as part of your working lesson.